And for those persons, since we don't have microphones, please make sure you're talking as loudly as you can so everyone can hear you in the room and on Zoom. So Dylan is joining us today from California, and he's the Director of Operations at XR Access, a research initiative of Cornell Tech. XR Access's mission is to modernize, innovate, and expand XR technologies, content, products, and assistive technologies, promoting inclusive design in a diverse community that connects stakeholders, catalyzes shared and sustained action, and provides valuable, informative resources. Dylan is an expert on accessibility for emerging technologies. He advises groups such as Meta, W3C, and the FCC on how virtual and augmented reality can be more inclusive. He chairs the annual XR Access Symposium, co-founded the Accessibility in the Metaverse Working Group of the Metaverse Standards Forum, and is responsible for many ongoing initiatives to connect disability advocates, technologists, academies, and others to key stakeholders to solve difficult problems in accessibility. We are so lucky and grateful to have Dylan joining us today to talk through the latest research in XR, showing how innovations in accessibility have paved the way for inclusive applications that work better for everyone. So thank you, and passing it over to you, Dylan.
All right. Thanks so much, Carolyn. I really appreciate it. Everybody can see my screen okay?
Yeah.
Awesome. So, hello. As Carolyn said, I'm Dylan Fox. I'm the Director of Operations for XR Access. Excuse me if my voice falters a bit today. I'm getting over COVID and have found it doesn't do great things for lung capacity, but we'll carry on anyway. So our agenda for today, wanted to talk first just about accessibility itself and the curb cut effect, which is a really important aspect of accessibility design. We're going to talk a little bit about the current state of XR accessibility, then talk about what the future looks like and how we can get to full XR accessibility. And finally, have a few resources for you and hopefully some time for Q&A. So with that said, let's talk about accessibility and the curb cut effect. So there's three very important terms I want to define for us here: accessibility, impairment, and disability, which are related but not the same. Accessibility means that something is usable regardless of your ability. Abilities come in all forms, like being able to see or hear or move freely or process information, and everybody has different abilities. Now, an impairment is something that hampers our abilities. So your vision might be impaired because you lost an eye in a sword fight or because somebody turned out the lights. And disability is a mismatch between ability and expectation, at least so far as the social model of disability. Someone using a wheelchair may be impaired most of the time, but they're not disabled unless the only way into a building is through stairs. So who is accessibility for? A lot of people think, when they think about accessibility, of perhaps somebody like this, who's Paralympian Ma Lin of Australia. He's a gold medal Paralympic champion and lost his right arm at age 5 when he stuck it in a bear's cage at a zoo. So if your mother tells you don't stick your hand in the cage, maybe listen. Now, when a lot of people think about accessibility, they think about people like Lin, who are those with permanent disabilities. And I should note that even though somebody is disabled doesn't necessarily mean they're not incredible at many different things, right? I'm sure Ma Lin could beat us all at ping pong single-handedly, so to speak. But there's an important other aspects of disability that a lot of people don't think about all the time. Temporary and situational disabilities, temporary situational impairments, I should be saying. A temporary impairment could be that you broke your arm and you have it in a sling for a little while. A situational impairment could be that you have your hands full. Now, all three of these, permanent, temporary, and situational, still result in the same net effect, which is that you don't have access to one of your arms. And the reason that distinction is important is because of something called the curb cut effect. So the curb cuts, first of all, are the little ramps that go from the sidewalk down to the street. You see all over the place. And you see them all over the place because of a campaign from people like Ed Roberts, who was a leading figure in the disability civil rights movement in the 60s. They didn't used to be all over the place. They used to be basically nowhere. People with wheelchairs would have to find the nearest driveway and then, take the street and dodge cars to get to the next block. Not a great situation. And Ed Roberts and his crew went around in the dead of night and took sledgehammers to the sidewalks and says, hey, you can either build this back the way it was and we'll sledgehammer it again, or you can build it back the right way and give us the accessibility that we need. And after all of this effort, after the cities started putting in these curb cuts, they found, well, hey, we may have put these curb cuts in for people in wheelchairs, but actually, it turns out they're really useful for people with strollers or suitcases or bicycles or dollies, for a lot of different people, right? And thus, the curb cut effect is shorthand for saying that when we design for disabilities, we make things better for everyone. And curb cuts are the most obvious example, but you can see the same thing happening in virtual reality. We have here the gravity gloves from a game called Half-Life Alyx. And these are very fun. They are a device in the game that lets you just kind of Jedi, force pull items to you. And that is incredible from a gameplay perspective because it means you don't have to kind of run over and stumble down and feel around on the ground for various bits and bobs of useful items. But it's also incredible from an accessibility perspective because it means that somebody who doesn't have that freedom to move around and to crouch down and to pick things up off the floor can still play the game. And so by, regardless of whether this was thought about in its conception as an accessibility feature or not, it still ends up being one and it still ends up making the game better for everyone. And I do mean everyone, right? When we're talking about accessibility, anything that we think of as a permanent disability also has temporary and situational corollaries, right? Again, you might have a limited amount of mobility because you have one arm. Maybe you have an arm injury. Maybe you're a new parent. You might have a limited amount of hearing because you're deaf, because you have an ear infection, or because you're just in a loud environment. And so I want everybody to keep in mind when we're talking about accessibility in the rest of this presentation, we're not talking about doing something as a charity case that will make it better for those poor souls that have to, use a wheelchair or use a cane or things like that. We're talking about making this better for you, for your parents, for your grandparents, for your children, for your cousins, for your dog, everybody. So with that said, let's talk about where XR accessibility is right now. So is XR currently accessible? We have a lot of great applications. We're seeing a lot of uptake of XR in education, which in theory is legally required to be accessible under the Americans with Disabilities Act. So is XR currently accessible? Not quite. But there's some caveats on that. So when we talk about accessibility, there's a well-known principle in design that says design for the extremes to benefit the means. So right now, most XR applications are designed to be usable for the quote-unquote average user, which in the minds of most XR creators means somebody who has functioning hands, ears, eyes, and a neurotypical brain, which is basically just this group here. But unfortunately, the idea of the average user is a myth. More than 1 in 4 people in the US have a disability of some sort, according to the CDC, which means that designing for only abled users means you're excluding a quarter or more of your potential users. Now, when I said there's a caveat on XR is currently not accessible, what I mean is that there aren't really any apps out there right now that are accessible to the full spectrum. No one application has every feature it would need to achieve that. However, there are some apps with captions, which might cover this section. There are some that are usable both seated and standing, which might cover this section. But I'll tell you this, if we can design solutions and standards that make XR accessible to people out here on the extremes, people have severe vision or hearing or mobility or cognitive disabilities, then you can bet it'll work for everybody in the middle. So let's take a look at some of the ways that we can do just that. An important principle that's going to help connect all of these examples together is the idea of modularity. Modularity means the ability to mix and match parts of a system. So when we use technology, we perceive input from a device, we understand what it's telling us and make a decision about what we want to do, and then we operate the application by outputting our commands to it. So, for example, you might get an input of a phone alert with a text from your friend, and the output would be to tap on the message to open it. And then you get a new input in the form of the contents of the message, and a new output in the form of the response you text them back. Now, the key to making this accessible is to make sure that there are multiple ways to get input and multiple ways to give output, right? So blind people can't get input through vision, and they tend to have trouble giving output via touch. But this is where modularity comes in. If the text messaging app can mix and match different kinds of input, like using text to speech and giving that via audio instead of using vision, and different kinds of output like keyboards or switch devices, then there's no problem. And so the way that people are accessing the technology might look totally different, but that function remains the same because you've modularly swapped out every piece of it to make it accessible. So looking at how this applies to VR, there's some great examples. So first of all, vision enhancement. And this section, I'm going to give you all stuff that is currently out there in existing products. This is not theoretical. First one I'll call out here is Walkabout Mini Golf, and we have a great seminar with one of their main designers, Colby Morgan. They have a magnifier so that you can basically take a closer look at some of these different pieces of information. You can change the level of magnification and just modify it to make whatever level of vision you have usable. On the right is The Last of Us Part 2, which is not a VR game, but it is a video game. And they have things like high contrast mode, where you can change everything out so that the only colors on the screen are blue for your allies, yellow for items, and red for enemies, and everything else is gray. And you could see how, for somebody who has limited vision, being able to make these types of tweaks can make all the difference between just having kind of a jumble of details and having something that you can actually get that critical information from in a timely manner. We could also talk about subtitles. This is a clip from our 2024 symposium, the design of Alchemy Lab subtitle systems. Big shout out to Alchemy Labs, which is a video game studio based out of, I think, Austin, Texas, who's made some games like Job Simulator, Vacation Simulator, this one, Cosmonious High, and they have really pushed the boundaries on accessibility. So we see here their subtitle system places subtitles at the depth of the speaker. It adjusts based on distance. It follows players' vision, and it can use opacity to convey depth. And these are all things that are kind of going above and beyond when it comes to VR subtitles, because in normal 2D screens, it's easy enough to just kind of slap subtitles on the bottom and call it a day. But in VR, you have additional challenges. You have the challenge of eye strain, constantly switching between subtitles that are close and the speaker that's far away. You have challenges of things getting obscured. If the subtitles are supposed to be hovering 2 feet in front of me, what happens if I hold up an object in front of them? Can I still see the subtitles? It can get very wonky very quickly. And so putting a little bit of extra thought and design into your VR subtitles is going to make them much more usable than, again, if you just take take what's being spoken and just slap it on the screen. And even that low bar is something that I think we don't see a lot of groups achieve, because there's a lack of platform accessibility right now. There isn't a simple way. If you go on YouTube, they make it easy to do captions. XR, they don't make it easy. You really have to kind of reinvent the wheel. But that being said, let's talk about mobility. So you want to make your XR applications more usable for folks with different levels of mobility. You do things like include a seated option, so people can play standing, seated, or even lying down. You want to make sure that it's usable with one controller or even with no controllers. You have non-hand related input methods. You want to have customizable heights. You want to have things like controller smoothing so that if you have spastic movements, that's not going to be a barrier to playing. And you definitely want to have switch controls and controller remapping so that if somebody can't hit a particular button, that's not going to be a barrier to them playing. I'm going to take a quick clip here again from Cosmonia.
To that end, we've added a one-handed mode.
Show you what they got.
Players can complete the game from start to finish using only one controller. With this update, we've also improved the player's seated experience. Tables and surfaces have handles that allow their height to be adjusted, putting our stations and objects within everyone's reach.
So they've got a lot more where that came from, but in the interest of just giving you guys kind of the whirlwind tour of accessibility, we can keep moving for now. Next area is cognitive. Now, practicing good design, accessible design when it comes to cognitive disability is in many ways similar to just practicing good user experience design. People with cognitive disabilities might have trouble processing too much information at once. Might get easily confused or frustrated and abandon your app if it's too difficult to understand. So rather than trying to, for example, front load somebody with a tutorial, dump a bunch of information in their head and assume that they'll remember it all, it's helpful to have things like contextual help. On the left side here, we have the menu from the Apple Vision Pro, which does actually a pretty good job of accessibility, other than the fact that it's $3,500. And you can see every option has definitions, right? It has descriptions. It doesn't make you guess at what it does, toggle it on, try to check what that actually did, go back, toggle it off. It makes it simple. Right. And similarly here on the right, we have Google Tilt Brush, which is a very fun app. I encourage everybody to try it. It has a beginner's mode where it hides some of the kind of extra complexity, all the extra options you might have, and lets you get started with just a pretty simple set of tools. And then when you're ready, you can explore the rest of those, but it doesn't just dump them on you all at once. So yeah, in summary, you want to make sure you're providing clear instructions, you have good tutorials, you have contextual help, and help that's available as people need it. And this also includes things like labeling your icons and trying to avoid, and this is actually a big one for VR, trying to avoid overwhelming people, because it's very easy when you have a screen 2 inches from your eyes and surround sound when you're in this immersive environment to get overwhelmed by sound, by vision. You don't want to have people, especially people with sensory challenges, who this can, lead to immediately triggering migraines or triggering panic attacks. You don't want to shove a lot of exciting things at them from the get-go. It's helpful to start people out in a place of relative calm. It's good to give people an emergency exit button if things are just too much, too fast, too loud. You want to meet people where they're at, and often that means toning down some of your biggest attention grabbing impulses until people are ready for it. And then finally, in terms of current accessibility, I just want to talk about diverse self-representation. Virtual reality especially is an area where people can really get immersed in their environment, right? And often that means choosing how to express themselves in that environment. It's really helpful to make sure people have options of how to do that for both visible and invisible disabilities that give people the choice of whether they want to present as someone with a disability or not, right? And that can include things like prosthetic arms or wheelchairs, as we see on the slide here. It could include things like hearing aids. There's also been some great research at Cornell on ways to represent invisible disabilities, right? You can give yourself maybe a little energy meter that indicates whether, people are okay to come up and talk to you, or if you maybe would just rather be left alone for now, right? Or other ways to represent disabilities. It's really important to make sure that people have the ability to choose not just for one global avatar, but ideally kind of differently for different environments, whether they are disclosing and representing themselves with a disability. Because as a lot of people will tell you, there's still a lot of discrimination, especially on the internet and in the metaverse. And there's a lot of people that don't want to face that and want to have a place where they can not stand out. But conversely, there's a lot of people that want to embrace disability as part of their identity and want to share that with the world and want to challenge people's assumptions. So, much like with our conversation of modularity, giving people the choice of how they want to do it and giving people flexibility is really the most accessible thing you can do. Let me pause there because I've just been chatting. Before we get on to the kind of future, let's see if there's any questions in the audience here or comments, or how you guys tell me what accessibility stuff or what accessibility challenges have you all noticed in VR? How about everybody first of all, raise your hand if you've ever tried VR before, because I'm curious about that. Okay, looks like everybody. That's great. So yeah, let me hear from you guys. What types of challenges or barriers have you seen? What does all of this that we've talked about so far resonate with you?
We don't have a microphone, right? So try to speak loudly. Okay. It's no problem for me. Thank you for all of this. I'm actually kind of going back to your opening statement of, right, is XR accessible right now? And in a lot of ways, right, the answer is no. I think a lot about the adoption curve. And for folks who maybe need accessible features, who self-select out of XR experiences because it is, right, at this stage, it isn't particularly accessible. And so as we do a better job of building accessible features into XR experiences, how we can make sure to encourage folks to try it out, to try the accessibility features, to see how it works, and kind of what the adoption curve, what ways that we can work on bringing the adoption curve down for folks who do have disabilities.
Yeah, that's a great question. I think a lot of that has to do with communities, with making sure that people like yourselves who are, up to date on modern technology, who have experience with these things, who are skilled troubleshooters, there needs to be connections between folks like yourselves and people who are disabled. A lot of the times, people with disabilities don't want to buy this technology because they assume, oftentimes rightly so, it's not going to be accessible for them. And so, in order for folks to be able to benefit from it, there needs to be people who can, basically run ad hoc tech demos or places, where schools that are doing this. You need to have librarians and other folks that are equipped and in contact with folks in the disabled communities to help them try these things out. So that, I think, is a big part of it. I think it's one of the reasons that we try to make sure to connect with folks at places like Lighthouse for the Blind, with places like Center for Independent Living here in Oakland, with all of these community centers that support folks with disabilities. And when you have that pieces of accessible technology, when you have things that could make a difference for folks, that you have those pathways to get them there. Because I think we've seen very frequently advanced tech, emerging technology can be a bit of a bubble, right? There's a lot of people that tend to just kind of share on their algorithms, which lo and behold, just circle right back into the people that are just like you. So yeah, I think building up that accessibility curve or that adoption curve by having those connections and having those communities, I think is going to be the best way to do it. Ideally, you do want to have disabled folks as co-designers, as team members. This shouldn't be seen as we're going to make it and then deliver it from on high down to the masses. It should be a nothing about us without us collaboration.
Very helpful. Thank you.
Mm-hmm. Any other question? Oh,
I'm sorry. So I've played Half-Life now, and the thing about that game is it's super immersive. The one thing I do most is with my game. And I know there's already accessibility, to help with that kind of thing, whether it's teleporting, I know there's dark at the end of the screen. Only thing that works for me is the teleportation where you move, but it breaks that immersion in the game that you want to go back in VR, especially in the particular part of the game that you're hiding from someone named Jeff. But that the accessibility, like that scene, is way more terrifying without when that immersion's there. When it's not there, it's just, I'm teleporting away. Yeah. So how do you balance? Well, I'm going to say, how do you balance giving people the accessibility to take do something and have an immersion that VR is going forward? So I haven't gone back to beat that game because they were well. It's like I avoided it.
So I didn't catch all of that, but it sounds like the question was about basically how do you balance immersion and accessibility? Is that right?
That's right.
Right. It's a very good question. And I think this is very similar to a conversation that often comes up in terms of video game difficulty and accessibility. You have games like Dark Souls that are hard by design. And oftentimes people decry any attempts to make them more accessible to people as, oh, you're gonna, you're gonna lose the vision, you're gonna lose what makes it special if you try to make it accessible. And I think what we've found in those types of situations is, first of all, that these things are not necessarily mutually exclusive, right? You can have accessibility features that may not necessarily be, yeah, if we're talking about the difference between kind of moving and teleportation, in some ways, I think, yes, moving is going to be more immersive, but in other ways, if moving is the way you kind of smoothly move like you're on a treadmill through the world, maybe that's going to be less immersive for people than just having teleportation, especially if that teleportation is kind of diegetic to the game. If you have a teleportation gun, like in there's like an Office Budget Cuts, I think, great VR game. Anyway, I think the big thing for me here is that it's better to have somebody be able to experience it, perhaps not quite as the designers intended, but still be able to experience it, than it is to cut somebody off entirely. I think if you want to include language from the designers to the users that says, "Hey, this is the intended way to experience this application," but we've included these features so that more people can experience it in their own way. A great example of this is Celeste. This is a video game where you're climbing a mountain, and by default, it is a very challenging game, right? The timing and level of kind of platforming knowledge and experience that somebody might need to get through that game is gonna make it inaccessible to a lot of both inexperienced players as well as folks who may have, motor disabilities. But they have in that not an easy mode, but an accessibility settings mode, an assist mode, I should say, that when you open it up, there's a message from the developers that says, "Hey, we didn't design, Celeste to be played with these, but here they are if you want them." And you can do things like turn the game speed down, right? You can give yourself infinite jumps or infinite lives or whatever. And is that going to diminish your experience of, struggle? And I think, a game is intended, you're supposed to die many, many times as you climb the mountain in order to get that experience of struggling up a difficult challenge. If you just turn on infinite jumps, yeah, that kind of goes away. But again, for like we said, 25% of the population that may have a disability, it's better to be able to play it with infinite jumps than it is to be stuck on the very first screen because you don't have the manual dexterity necessary to progress. So I think it's fine to say that this is the way something was meant to be played. This is the way that you should do it for maximum immersion. But if you don't have those accessibility settings that let people experience it in their own way, you're going to lose them from the experience entirely. And I think that would be a shame. Anything else before we go on to the kind of future-facing research part?
Yeah, question. Can you hear me?
A little, barely. Speak up.
I'll try to speak up here. Hi, I'm Matt. So I am a victim of VR motion sickness. I remember getting it when I was taking the International Space Station VR experience on Oculus. Do you have any strategies for counteracting that, or things that could potentially be used when designing the experience to reduce that, such as motion blur or reference artifacts, anything that you found helpful?
Yes, there are definitely a number of techniques that designers, developers can use to minimize motion sickness. I think first is just to avoid forced movement, avoid acceleration. Anything where you pick somebody up and shove them, or like have somebody fall into a pit and experience falling, is a instant ticket to nausea. Other helpful things include certainly including options for teleportation instead of smooth movement. Having things like snap turning, where you use the control stick or hit a button, and it snaps you 15 or 30 degrees at a time instead of smoothly turning you. There's vignettes where when you're moving, you can kind of bring darkness to the edges so that you can only see in the center. There's some advanced techniques that, as of a few like 2 or 3 years ago, I tried a demo of, where they stuck you in a VR roller coaster, and when you reach one of the curves, it has little dots that kind of appear and move in the opposite direction of the curve, and that apparently, I don't know the neuroscience of it, but that type of thing can help reduce motion sickness. So there are definitely a lot of tools in the potential toolkit for that. There's some very great papers that I think if I they're not on our GitHub already, I'll be sure to add them after this. But it is something that should be conquerable for a lot of people, especially for VR environments where you're really not moving around a lot. Awesome. Let's go ahead and talk about some of the other kind of upcoming research here, and then we'll have more time for chat at the end here. Um, what is it going to take to make VR fully accessible? And let's start with one of the big ones, which is people. How can people that are fully blind enjoy VR? I think this is something that we've heard from a lot of folks, a lot of skepticism of, oh man, VR is such a visual medium. How can we possibly make it accessible? To which I would say, well, reality is also a visual medium, and yet we've managed, right? The thing is, though, is that for this, we need better tools than the ones we've used for 2D. There is a very common tool called a screen reader. That is what a lot of blind folks use to access most technology. And what a screen reader does is it goes through and kind of reads things out one at a time, so that you don't need to visualize them. You can just listen to them. So if we have this spreadsheet here, it would read place, A2, object, people, C2, Tom, Richard, C3, right? Just kind of reads it out one by one. You can imagine trying to do that for a virtual reality environment would be tricky. Excuse me. But there have been proposed ways to get around this. There's an amazing paper and prototype produced by Microsoft along with folks, I want to say at the University of London, called Scene Weaving, which is an interactional metaphor to enable blind users experience in 3D virtual environments. And the way this works is a combination of top down and bottom up design. So you do have, first of all, in terms of exploration, you have the ability to send out basically a pulse. And as that pulse expands, you hear objects that it encounters, right? So you might hear desk, microwave, fan, and you hear those spatially using spatial sound from where they actually are in the room. So by doing that, you can get a sense of what's around you. Alternately, instead of having it expand outwards from you, you could have a cone of vision where anywhere you look in this cone, it reads what you see, right? So you have right there two ways to just kind of explore the space. Then you can have, in the top-down style, that kind of screen reader style, where you have a list of perhaps rooms. You have the kitchen, and then in the kitchen you have the oven, the refrigerator, and for each of these, it gives you the option to get details about the object, navigate to it, interact with it. This kind of menu-focused, top-down exploration of the space. There's a lot more that they put into this. It's a really amazing prototype, and if you're interested, I encourage you to watch our seminar with them about it. But this type of thing is absolutely a possibility in almost any VR situation. We just haven't really tried to implement something like this outside of a research context. But it is possible, and it should be viable. Another technique for blind navigation is sighted guides. So if you are blind in real life, and you get to a space that is unknown to you, one technique you might use is ask somebody for help. You ask somebody to be your sighted guide, and this person can answer questions about the environment. They can offer you their elbow, and you can grab it and have them kind of guide you around to wherever you want to go. There's no reason that we can't do this in VR. We have a paper from 2023, Jasmine Collins et al. At Cornell, cited guides to enhance accessibility for blind and low vision people in VR. That ability to, for example, grab somebody by the elbow and have them lead you around isn't typically something that exists in VR, but there's no reason it couldn't be, right? And having these types of techniques that we've just copied from real life are some very viable ways to make VR more accessible. Especially when you consider the fact that those sighted guides don't necessarily need to be human. AI is obviously seeing an explosion in different use cases, and one of them is visual interpretation. We have services like Be My AI from Be My Eyes, where you can take a picture of something and just have a conversation with an AI about, hey, what's in this picture, right? There's tools like this one, Glidance, which is making a guide robot and wayfinding AI that may look like a Tinker Toy, but is really quite good apparently. I've tried it myself at helping to guide people around obstacles and identify what's in the environment. So some of these machine learning tools are incredibly powerful in these applications, and I think we're still just waiting to see a lot of the mainstream applications, mainstream platforms apply them in this way. Excuse me, COVID throat striking again. Let's also talk about switch controls. So switch controls, for those unfamiliar, is basically a means for folks with motor disabilities to use simple switches to interact with technology. So if you can't use a full motion controller, what you might be able to do is hit a switch that is mounted to your wheelchair or to your neck rest, or use something like a sip and puff controller, where you can use just your mouth to select and then either sip or puff to, do option 1 or option 2. There's a lot of techniques like these for established technologies. Most of them, however, are not yet compatible with VR. I think we're starting to see exploration of Bluetooth switch controllers, but there are unfortunately a lot of compatibility issues that are left to work out there. And there's also a challenge of button remapping, right? Because when you're using an Xbox controller, it's easy enough to say, okay, the function that would be on A, remap that to right trigger. And then somebody who can't press A, but can press right trigger, has no problem. Or not only map it to right trigger, map it to this, cheek button that I hit with my cheek, right? But with VR, part of the kind of selling point of VR is immersion, is motion controls. Those are a little bit harder to remap. There is some great work that's been doing it. We had at last year's symposium, maybe this year's, an amazing set of Lemmings, that's what it's called, which is this project to let you redefine things like maybe instead of a pinch being this, a pinch can be this, or any type of kind of custom defined movement option. So lots of work that's being done in this, but still a lot more work to be done, both in terms of defining how this should work in theory and making it work in practice such that these devices can actually connect to the hardware that people are already using. Oh, yeah, I'd love to show you now. This is a quick video that kind of shows how this might work from a group called the Virtual Experience Research Accelerator that I've been working with.
Again, with the interactables, you have to highlight and select and use the open interaction and moving forwards and turning around to go towards the gate or towards the cannon and just using the movement interaction menu to get there. And again, to the selection to see if the can's an interactable and select it and use the interaction button interactions for the cannon. As you can see, researchers can use basic interactions such as pick up and drop and throw, and they can also use custom, more complicated interactions like things like aiming and firing a cannon.
So I would bet before I showed you that video, a lot of you would have scratched your heads if I asked you how could somebody who's a quadriplegic, walk through a VR castle and fire a cannon at a pumpkin. But there you have it. These types of capabilities are firmly within our reach. It's just a matter of, are we designing them into our experiences? And so much of our work is not just defining how these can be possible, but encouraging people to make them a reality. A few more pieces of tech that I'll highlight in terms of up and coming research. Haptics for people that may be blind and or deaf. There's some incredible work being done with haptic gloves. Specifically, these are the haptX gloves, which have the capability of giving you force feedback, not just vibrating, but you could close your hand around, say, a digital water bottle, and it would stop your fingers as though you were actually holding it. It can also give you a lot of really defined feedback of, vibrate my left pinky, things like that. There's also research like this piece, Stretch or Vibrate, rendering spatial information of static and moving objects in VR via haptic feedback for blind people by Jiaxing Li et al. At University of Maryland 2024. They were experimenting with being able to perceive objects through touch, where they would have this basically device that would come, touch the back of your hand, and then either slide forward or backwards or right or left, and could use that to communicate to you, hey, there's an object forward or backwards or right or left, using nothing but touch. This is a prototype. Doesn't really work if you're waving your hands about, but this type of research is really paving the way for anybody who wanted to try to turn this into a product and try to give people, again, not just blind people, but anybody, a much more immersive experience and more channels to play with when you're designing these experiences. Also mention, I think one last one here, brain-computer interfaces. This is a really exciting field. There's a group called Cognition that's been making a device aimed at helping people who are really severely disabled in terms of like being unable to do anything other than move their eyes, or maybe not even that. Have access to easy ways of communicating, easy ways of browsing the internet and of operating Internet of Things devices, and giving them control over their space and over their lives. We also see, and this actually is just launched from Meta, there's SEMG wrist control. And this is a controller that operates by reading the nerve signals that pass through your wrist, which means that it works even if you don't technically have a hand. It can still access those signals and potentially give you some apparently pretty precise inputs, good enough for things like handwriting. So these types of interfaces, again, are coming into, or steadily becoming reality. It's just up to us how much we are able to actually incorporate them into the experiences that we're creating. So that is a little preview of some of the things that are coming out. I want to give you a few resources, and then we can spend the rest of our time, and our moderators can tell me how much that is on just having a conversation. So first of all, we have a number of research webinars on a lot of the things I've talked about here. If you just go to our xraccess.org/YouTube, we have some really great seminars. We have some great community discussions. We have all of our XR Access symposiums online. So definitely access those. Excuse me. We also worked with the XR Association to create an XR Access GitHub. This is a less a code base and more kind of an index of resources that folks can use to make their experiences more accessible. From standards to open source code, Fusion, to all kinds of different tools and capabilities. Then we also have the XR Association Developers Guides, one on accessibility, another you all might appreciate, immersive learning for secondary education. You can get those from their website. Great resources just to give you kind of that high-level view of a lot of these subjects. And finally, there's a lot of organizations that are working on these types of things. Obviously, us at XR Access. There's groups like the VR AR Association, Educators in VR, the Virtual Experience Research Accelerator, the Virtual World Society. There's a lot of people that care about making VR a more ethical and accessible technology. And so if you are interested in starting a project like this, definitely first thing, like reach out to some of these communities because we can really help start you on the right path and help you avoid reinventing the wheel from scratch. So I think I will leave it there. This is my information. Feel free to reach out. And with that, I'll open it up to some questions.
We have about 10 minutes for questions. Okay,
Go, go.
I can start off. Dylan, do you hear me? You hear me?
Yeah, I hear you guys for the most part. Just speak clearly, and I can get most of it.
So what is this one emerging trend that enhances XR accessibility that you're most excited about?
Say again, what aspects am I most excited about?
Yeah, what is this emerging trend or standards around enhancing accessibility?
That's a good question. I think we have seen definitely some advances. I think we've seen things like Apple Vision Pro launching with all of the accessibility features from iOS and then some is huge. It shows that a lot of this stuff can be done. We have things like Meta incorporating a screen reader into their platform. Still pretty rudimentary for the moment, but it's definitely a big step. As well as releasing their SEMG controller, excuse me, which I see very similarly to the Microsoft Kinect, which, if anybody remembers, Kinects are these released many years ago now to go with the Xbox as a peripheral through a camera that let you basically very easily capture people's hands, feet, kind of head, and do basic motion tracking. When Xbox launched them, it was very much just a here's a peripheral so you can play Just Dance. But then there were a lot of people in the research community that saw these and said, holy, you're telling me there's a cheap off-the-shelf device that I can use to do full motion tracking and it kind of just works. I don't have to buy a bunch of components and scrounge something together. And it sold like hotcakes in a lot of the research and kind of hobbyist communities. And I see this type of SEMG wristband functioning in a very similar way once there's some open source versions of it. So I think the fact that we're seeing these new input devices, the fact that we are seeing AI be able to help bridge some of these gaps where the creators don't. You can see on our website, we just had a great seminar by Daniel Kilo on XR Site. They made this giant database of labeled VR interactions so that an AI could tell you what's happening on the screen with at least some level of accuracy. Obviously, that's not as good as accessibility being baked in from the start, but it's something. And I think we're starting to see a lot more flexibility. And when we talked about adoption curves, I think even having these imperfect tools could help get people involved and help raise the pressure to put accessibility in properly from the start. So I think there is definitely stuff to be hopeful about.
Thank you. So yeah, you're sitting in a room with a lot of people that are working on like online tools, and we have a new initiative to sort of like work with online modules to distance learners. And so like a lot of these resources are sort of VR based or like headset based. What kind of tools are really like we're interested in for this for like WebXR, augmented reality, or like screen based like interactive components? What accessible resources or, as Moiso asked, trends in that space for like web experiences are of your interest right now?
Yeah, that's a good question. I think certainly WebXR has come a long way. I think there's still some kind of challenges in that unlike HTML, where the screen readers have access to effectively the full structure of the page, a lot of things like Unity, they kind of compile all of that and then send it to you. And so it's like trying to have a screen reader function by taking a screenshot of the page instead of having access to the HTML. And I think WebXR has a big opportunity to, again, be that kind of HTML of XR, right? Where in theory at least can have accessible technology that interfaces at that level. I'm not involved with the groups at the level of detail that I can tell you the exact stuff that's going on in that space, but I think certainly things like that. I think the fact that XR is getting cheaper. You have some of these headsets that sell for $200 to $250. You have some of these AR glasses that are coming out as well, make it a little bit more viable to send somebody a headset. But also even just with regards to the web-based interactions, I think we are seeing a lot of the stuff that relies on just things like basic camera input. You have more capability now than you had before to kind of tease out things like depth relationships, to have a computer take a look at a scene and be able to identify, oh, that's a table, that's a chair, that's the floor, that's the wall, and kind of build up these 3D spaces. It's definitely one of those spaces that I think is developing pretty rapidly, and I certainly hope to see more accessible stuff come out of that. And if you can manage to make it, then send it to me, and I'll stick it on our GitHub for sure.
Well, thank you.
Mm-hmm. Any other questions, comments, any other fun projects you all want to share about? I'd love to hear what you all are working on too.
My name is Esther. I work on the data management side of things. I don't know anything about HTML or any of the things that the other people in this room do. But I am curious if you can talk a little bit about how you quantify success, and from a metrics and data standpoint, what you consider like a quote unquote good threshold of accessibility, especially given that there's so many different kinds of disabilities, and what kinds of data do you like to have as your kind of like starting lineup for assessing success?
It's a very good question. I think part of the challenge we've seen with XR and XR accessibility is that a lot of the old standards don't apply, right? If you're looking at something like trying to do an accessibility audit, I was doing some consulting work and I ended up doing this kind of weird hodgepodge of like the WCAG guidelines, the XAUR, it's the XR accessibility user requirements kind of prototype stub, the game accessibility guidelines, like it's a real kind of mix and match smorgasbord. What I think we've seen, well, we're working first of all on the Metaverse Standards Forum Accessibility Working Group. We meet every other Tuesday to try to talk about. We're closing in on our first draft of what should standards be, so that ideally you can actually have an audit done and see whether some of these applications are meeting that criteria. In terms of measuring success, I think a big part of it is what proportion of your people can actually use the technology, right? And not just use it, but actually have it be usable. Because there's a big difference between, yes, this is technically accessible. You can have, the screen reader read it out painfully, one agonizing line at a time, versus you have an equivalent experience. So I think measuring, who can use it, what percentage of people can use it, what percentage of people can actually have an experience that would be considered equivalent. It can be very helpful when you're doing things like procurement to have people put in a VPAT, which is a voluntary product accessibility testimonial, I think, where they try to convince you and say, hey, this is the accessibility features we baked in. I think there's also, you want to make sure that any testing you are doing, any of the criteria that you already have, can you filter by people with disabilities and see how big of a drop in performance you get? Because that delta is another thing that's important to measure, right? That one can be tricky because it can be sensitive to gather information about people's disabilities. But if you can measure what's the difference in success rates or any of your current metrics between abled and disabled people, I think that can give you some insight into how good of a job you're doing on the accessibility front. So I think those would be a couple of the main ones.
Thank you. You have time for one more.
Going once, going twice.
All right, I gave Thank you so much, Dylan. Really appreciate it.
Absolutely. Well, thanks very much, everybody. And like I said, if anybody wants to chat, wants to workshop ideas on accessibility, feel free to reach out, because that is why we're here.
Appreciate it, and we'll send everybody resources after the presentation. Thank you.
All right, thanks all.
Thank you.